So without further ado, I'm going to turn it over to Adam. And again, Adam, when it comes to gearbox selection, where do we start?
Well, the first step is understanding what your application is. So there's many different applications that do all kinds of different things, especially for our product specifically. They're in a little bit of everything. Mining, food and beverage, forestry, whatever the case may be, they're all over the place. So we really need to start with your specific application that you're working with and learning as much about it as you can, just by seeing the application, getting as much information back as you can. And we have some examples here. So this is just a video of these different applications. This one is a crane specifically, but if you look at simple, there's the gearbox to the right. It's turning a set of gears, and it's winding a cable, or it's moving the crane, whatever the case may be. Relatively simple. But then you get to this specific application of railcar dumper. Just appreciate the size of this. Everybody knows how big a train car is. That is massive. That's a lot of weight. There's a lot of things going on here from a gearbox perspective. The gearbox has to hold that weight. It has to turn that weight. And then when all that coal, in this case, dumps out, all that weight goes away. It shocks back to the system. And then when it rolls back, all that weight shocks back. So you have to understand everything that's going on here as well. It's not even pictured, but down below this, there's another conveyor that's taking the weight as well. So depending on which gearbox you're looking at, we have to understand what it's actually doing to pick the correct one.
Gotcha.
So huge amount of load, a lot of different forces going on there. We want to make sure we understand everything that it's doing. And when you watch it, it comes back softly, but that's still a lot of weight coming back down on that little chain there that's holding all that. And then you have a slightly different application, not very heavy. It's just rubber going through a set of pulleys, but it's a constant speed. There could be some high temperature there. Just looking around at the application, you can almost see certain things. They may be monitoring temperature there on that panel, or it might be a variable speed application. So you need to understand how fast it's going most of the time or all the time. If it's a constant speed, a lot of different factors you can just see from looking at the application.
Sure.
Now, it takes some experience. Obviously, you need to see different ones over time, but in a lot of cases, it's right in front of you. You just have to understand what it's doing. So you see this one will cut it. So there's a little bit of a load there, but not too much. And it's a totally different application. There's a lot going on here. So this is a bucket elevator, what we call it. So it looks like a conveyor in the sense that it goes around pulleys, but we have a chain and sprocket that pulls it around. So every time one of those chains hits the sprocket, it shocks the gearbox system. Every time one of these buckets fills up with whatever material, that's an extra weight on the gearbox as well. So all of that has to be taken into account for when you're making the gearbox selection. It's not just as simple as speed and ratio.
Sure. So a lot of different factors when it comes to the application itself. And I assume we can't use the same gearbox for every application.
Correct.
Right?
So on paper, design-wise, like we have in front of us here, it may be this style, but the size is going to vary based on torque capacity, horsepower requirement based on the application. Theoretically, it's the same gearbox, but size-wise, it varies very much.
Gotcha. Okay. So now that we know a little bit about the application, what's next?
Let's start the selection process. So there's a few factors we call them service factors or safety factors, however you want to look at it. It's essentially, you have your base selection, but then you always put a little bit on top of it to allow for and prevent failure with these other types of unknowns, if you will. Yes, we know how much weight is moving, but if for whatever reason that little scoop in that example grabs more than the next one, we have to be prepared for that. So always want a little bit of a safety net to make sure you're covered for that.
Okay.
So these are all recommendations. They're in our catalog from AGMA, American Gear Manufacturers Association, but they're out there. They're all industry recommendations, but based on the type of load. So we showed you those applications before. There's 3 classes of load. So we have uniform load. You can see it here. We have a video here in a second, but you can see uniform load. The loading is nice and steady. The speed doesn't change. The load doesn't change very much. It's a constant, relatively constant flow. But then if we switch to there's different classes for each one. Then we switch to a moderate, the loads a little bit more. It's a little bit faster. Things can change more erratically. So that's more moderate there. And then heavy shock, as you can see with the red line there, it's all over the place.
Yeah.
The shock doubles in size. Sometimes it's not very much, but other times it's a lot. So something like that is definitely considered a heavy shock situation.
And we've got some examples here, right?
Right. So there's three applications here. We'll go into that video. So as I said, uniform load on this baggage conveyor, you can see this piece of luggage is moving nice and smooth. It bumps a little bit on the split there, but nothing major. You definitely want to think about that. I mean, it's going to move. This one's going up a circle. Most of the time they're flat, steady speed. We don't want flying off the conveyor, so we keep it nice and slow. Things like that. That's definitely a uniform load.
Okay.
And as we move to the next one, the moderate. So debarker, this is in the wood industry. So that's a huge tree. So that's probably a foot in diameter. All that weight is on that conveyor. So that gearbox is taking that weight. But then you have that blade spinning that's taking the bark off. You have that roller that's sitting on there. And if there's anything in that wood that blade hits, that shock is going to go back to the gearbox.
Yeah.
So you have to be prepared for that. So it's the unknowns is what you're really looking at. And you can see the size of the blade and how fast is that spinning. If that were to hit something, say a nail or something grew into it, something stiffer than the wood,
Sure.
it would break it. It could potentially break it and hurt the gearbox essentially and everything else.
Makes
So
sense.
you have to prepare for those unknowns. And then high shock, you've seen this one already, this Railcar dumper. So it's not shock yet, but as soon as that dumps, that whole car is moving around and bouncing back. And that's a high, heavy load that's shocking back into the system. And same thing, as I mentioned below, all that coal is dumping on that conveyor. So that gearbox has to be prepared for that shock load as well, because that's a massive amount of weight dumping down onto that conveyor. So that would definitely be a high shock application.
And with so many different applications, I can imagine that, there's a lot of differences between those applications. Like, how do we figure out if it's a uniform, a moderate, a heavy? Like, what's going to guide us there?
So we do have some recommendations. So this is cut from our catalog specifically. This is recommendations per AGMA, American Gear Manufacturers Association. They go by type of industry, a type of application within the industry, and that's strictly a recommendation. There's other companies out there, SEMA, PTDA, there's different companies out there that'll have recommendations for what type of loading. But if they're not, if your application specifically isn't shown here, try to understand the most you can out of the application. So know the speeds, know the weights that it's moving. If it's moving little tiny pebbles, then it's probably moderate to uniform. But if it's moving large boulders, it's definitely heavy. So you kind of, I hate to say learn as you go, but you understand what it's going through when you see what it's actually doing.
But for the most part, I mean, a lot of the applications that are out
This is
there
2 pages
pretty
long,
comprehensive.
so there's a lot of information out there. Yeah.
Okay. All right. So what's next?
So next we want to determine, you want to look at how long it's running per day, and then kind of apply a service class to that with a load factor, we call it, class 1 through 3. So different loading, as we said, and then we tie it to the type of runtime it has per day. So if it's running 24 hours a day, as you see, even if it's uniform load, it kicks it up to a class 2. Because 24 hours a day, it never has a chance to cool down. The lubrication never has a chance to cool down. It's just working harder. But at that same unit, if it's only running a half hour per day, it's only class 1. So you don't need that big of a unit for this particular application.
No, but these classes, like, what do they mean for the selection process in your gearbox?
So class 1 typically is a smaller torque rating, smaller size, smaller frame size. You get up to a class 3. The horsepower could be the same, but the physical size of the gearbox is bigger. The bearings are bigger, the gears are bigger to be able to handle the heavy shock loading and the constant run time.
Sure.
So physically, they will get bigger with a larger class.
Okay.
Now, another service factor on top of that, along with the classes from before, is that what we call our service factor, or our safety factor. So these are recommendations from AGMA based on the loading and based on the run time per day. We apply a service factor on top of the demand horsepower of what your application requires. So we take that times it by this service factor, and that's the minimum we need for our gearbox to be rated for.
And
that way we know it'll be rated for that application.
Okay, so you said a safety factor. That's
correct.
So we're building in some type of safety with the application and our selection. Right?
Correct. Knowing what we know about the application, knowing the loading that we're seeing, we're adding that extra safety net on top of what we calculate is the required power for the application.
Gotcha. I'll ask another question. We've got cyclo listed here and 2 different figures.
So yeah, so there is a slight difference. So Lee had mentioned it last week. Cyclo is a slightly different gearbox. It's really no gears in it. And because of that, the load sharing capabilities that it has, with that extra load sharing, it can handle heavy shock with a slightly less service factor. So for example, heavy shock, we're significantly less for service factor on that because of the cyclo design. It can absorb its load sharing inside that cyclo, and it can take that abuse more so than your typical involute gearing.
Gotcha. Okay. So what other factors do we have?
So the other one is it starts and stops. So runtime was one thing. So that's your consistent run. If you're running 6 hours a day, 10 hours a day, et cetera. But then if there's starts and stops. So if you have an application that's, we would establish it's running 6 hours a day, but of those 6 hours, it's stopping 200 times in that 6 hours. You have to account for that. Because when you're coming to a start and to a stop, everything inside that gearbox is coming to a stop as well. And if it's a high-speed application, let's say, all that inertia is going back into the components and everything is taking the hit. So you definitely want to allow for that and compensate the selection for that. So it would get larger. That's where it's an additional service factor. So we'd start multiplying service factors to get it to a higher selection. A beefier selection would be the easiest way to describe it.
Gotcha. So this is a supplemental above and beyond.
Correct.
The
so you have the
service
AGMA reference one, and then it's just a supplemental one on top of what we've already established.
Yeah. Okay.
So one last thing is the environment. So we know all these applications or everything around them is different. So we have this little video here. It doesn't change the physical size of the gearbox in most cases. It's strictly the options for the gearbox. So in this food protein, so this is food and beverage, there's coatings and such for the gearbox to make sure they last longer, that they don't collect bacteria, so they don't rust. Because in these applications, you definitely don't want rust. But at the same time, they have to be prepared for these type of cleaning processes as well.
Yep.
So here they're just using water. But in some applications, there's high pressure water, which is you got to change seals, you have to change your breather. And then we even have chemical wash down. So whether they're cleaning food or cleaning whatever the application may be, blood in some cases for the food and beverage industry, cleaning that off, the gearbox has to be able to take that as well, because some chemicals are caustic enough to eat through the material. Same thing here with high temperature, high or low temperature. If it's too hot, we change the oil. If it's too low, we change the oil and change the breather, change the seals so they don't start cracking.
Yep.
If it's indoor, outdoor, we change different things. All these different things going on here, we have to remember to compensate for on the options side. Because like I said, it doesn't necessarily change the gearbox physical frame size, but it may change what options we put on the outside.
The accessories, the coatings.
Correct.
Gotcha.
Correct.
Okay.
So this one here, high altitude, high dust and high debris, mainly high altitude. This one can change your selection because at high altitude, the air is thinner. And from there, cooling isn't the same. So you need to compensate with a slightly larger box to make sure it stays cool in certain applications. So if it's running constantly, it'll run a little bit hotter at a higher altitude because the air isn't as good.
Our
for
gearboxes
cooling.
Get headaches.
Yes, they
That's
do
a
get
high
headaches.
altitude joke,
Yes.
yeah. Okay.
And high temperature as well. So here's a steel mill. I mean, these are rolling these ingots right off there. They are glowing hot, and there's gearboxes right there. So they have to either have a heat shield in some cases. High temp oil wouldn't help right there, but definitely a heat shield would definitely help. You got to be prepared for that. Same thing for cold.
Low temperature.
We
yep.
can't freeze.
Cold.
If the grease is cold or the oil is cold, it's not going to lubricate correctly. And inside a freezer like that, it's going to be very cold.
Yeah.
So we have to be prepared for that. But from there, you're ready to select the gearbox.
Okay, so we got a couple different things, right? We got the service class, service factor,
Mhm.
duty cycle, and then our environmental and external applications. So once we
Correct.
know all of those things, we're ready to
You
select.
fully understand what the application is
Yep.
doing. You have a good understanding of where it is in the country or the world, wherever the case may be. And now you can go ahead and make the selection on the gearbox.
So I think we've got a good selection problem here.
Yep, we have a little application
Yep.
homework here.
Yep. Okay, so
You want
I'm
to
gonna,
read through
yeah,
that?
I'll go ahead and read this. So we've got a situation. Jay Amen, the site supervisor at DB Rock and Quarry, needs to replace his shaft mounted reducer. He's frustrated with the current speed reducer because it's the third time this year that the barge loader conveyor has been down because of the speed reducer. When the box isn't breaking, the motor keeps tripping out. So the application, he's got a 20 horsepower motor. He's driving a 30-inch drum and figures he needs about 36,000 inch-pounds to move his load. The conveyor runs for 9 hours each day consistently. Since the motor's been tripping out, he's been measuring the motor load and notes that the peak operation the motor's pulling about 28 amps for up to 7 minutes, and the conveyor needs to run about 275 feet per minute. So there's a lot of information.
There is.
So, I mean, maybe let's just boil it down to like, what are the things that we need to know
Right.
when we encounter a situation, an application like this?
Right. So the customer gave you this information. It's time to really drill down to exactly what we need to know. So if you want to take some
Yeah,
notes
I'm
there.
going to take some notes.
So first we need to know what application it is. So
Okay.
we need the application info. So what we've determined, he works at a quarry. It's a shaft mounted reducer. So it's a conveyor.
Okay.
It's a conveyor application. Next would be the duty cycle. So when is it running? How much is it running?
Okay.
So if we kind of highlight the things he said here, it runs for 9 hours each day. So we can write that down. So that's our duty cycle. And he says consistently there as well. So that means there's no starts and stops. So you don't have to consider that in the application. When he starts it, it continues for 9 hours a day until they hit the stop button.
Okay.
Motor horsepower. Now he calls out he has 20 horsepower currently, but he also does say that the motor keeps tripping out. And since it's been tripping out, he's been checking the loading. So we'll put a question mark by that 20 horsepower. We may want to look into that since it is tripping out.
Gotcha.
Well, let's collect everything else first.
Okay.
The demand horsepower or the application required horsepower.
We don't know that yet, right?
No, we'll calculate that. Yep.
Okay.
Drive pulley size. So what are we turning? Which he tells us here, it's that 30-inch drum.
And I'm assuming we don't always have a drive pulley size.
No,
like
it could be. So this
shaft.
application was just a pulley, but it could have been chain and sprocket or the mixer screw. What is their required speed? And with this application, we need the diameter to get that speed.
Sure. Oh, gotcha. Okay.
Belt speed. So how fast does he want his end product to move? So that's this 275 feet per minute there.
Okay.
Yep. And then the motor speed, which in this case is a standard. So in North America, 4-pole motor, 1750 RPM is a standard. He doesn't say it specifically, but we know where we are in North America. So it's a 1750 RPM motor. If it's not 1750 for whatever reason, they would let us know that it's not a standard 4-pole motor.
Gotcha.
And gearbox ratio, we definitely need to know that. We don't have that just yet, but we'll calculate that based on the speeds that he needs. And then also the service class and the service factor, as we mentioned before.
Okay.
Okay, so we have an idea of everything we need there. So let's go through and gather as much as we can. We got everything he gave us. So now we can fill in the blanks. So we know it's a conveyor. Go back to our reference chart that we saw before. It's a conveyor. For example, it's a moderately loaded conveyor, so we know it's moderate. So moderate shock load. We know it's running 9 hours per day, so that's up to 10. So it's a class 2 of service, so we can fill our class 2. Same thing with the same shock load. We can get our service factor out of that. Shock load with a moderate shock at the same runtime, 1.25 is our service factor. And since starts and stops, we know there's no starts and stops, there's no supplemental. So that's the only service factor we're going to work with is that one right there.
Gotcha.
That's where I mentioned there. So no, the supplemental can be ignored. Now, the environment on this one, this is the picture the customer gave us. So we can see the conveyor here. We can kind of gain a lot from this just by looking at it, but there's water. So there's the potential for it to be high humidity, ambient moisture just from being that close. It's in Mississippi, so we understand that it's very humid down there, could get wet. We just have to think about that. Doesn't change our selection, but we have to think about it moving forward.
Gotcha.
Okay, so let's go back to the motor horsepower. He said it kept tripping out. So when a motor is tripping out, that means it's being overloaded in most cases. Sometimes it can mean there's an issue inside the motor, but for simplicity's sake, we'll just say it's tripping out because there's a sizing issue. Maybe it's overloaded, maybe it's being worked too hard. So let's double check this. So he said his 20 horsepower motor was pulling 28 amps. So if we looked at the catalog for the manufacturer's catalog for that motor, and we double check what it's rated for. So this particular motor is rated for 24.1 amps. Now he's pulling 28, so that is higher. However, motors do have a built-in service factor to them. NEMA standard service factor in most cases is 1.15. So we'll just assume that. So we'll take that 24.1 that is rated for times the 1.5 service factor. That gives us, this motor can take a 27.6 amps momentary and it'd be okay. He's pulling consistently 28.
Yeah.
So it's safe to say here, this motor is undersized. So we're going to kick it up to the next larger size motor, which would be a 25 horsepower. So we'll change our 20 horsepower up to a 25. Okay. Just because we know safe. This one's having an issue, we want to be safe. We don't want to keep having that issue pop up.
Okay. So he's got a 20 horsepower motor now, and we're going to say, hey, we would recommend you go into a 25 because that keeps tripping out.
Correct. Based on what we're seeing, you're pulling too much amp for the motor that you have. So now we can go on our demand horsepower there. We can figure out how much our gearbox has to be rated for. So we have that 25 horsepower that we just picked. We have our 1.25 service factor based on the AGMA service class, moderate shock for up to 10 hours a day. So we do 25 times the 1.25. So we need a demand horsepower rating of 31.25 horsepower. Our gearbox has to have that as a minimum rating to be able to move this load and have that service factor on top of it.
Gotcha. So that's where our service factor comes into play.
Correct. So that's service factor to the application. So
Gotcha.
you're only putting 25 horsepower to it, but we need 31.25 minimum on the gearbox side.
Gotcha. I'm following you.
So now you're tracking me.
I am.
So now we got to figure out the speeds. So from the speeds, we get our ratios. So he wanted 275 feet per minute, and we have that 30-inch pulley. So to get that, we use the conversion factor, 275 feet per minute divided by the 0.262 conversion factor times the 30-inch diameter of the drum pulley. That gets us our output RPM. So what we're doing is converting the feet and feet and inches back over to revolutions per minute.
Okay.
To get to that final RPM. So that's our output RPM. So that's the RPM of that pulley.
Gotcha.
That's what he needs it to be to get to that 275 feet per minute. So from there, we can figure out our gearbox ratio because we already know the motor speed. That's the standard 1750. So to get the total ratio of the gearbox, we take the input RPM divided by the output RPM, simple division,
Yep.
and that gives us 1750 by 35. We need a 50-to-1 ratio gearbox.
I know that we did that in our last session.
That's
so.
right.
Okay, so 50 to 1.
So 50-to-1. Now, if you notice, we have everything we need there to make a selection.
Looks like it.
Everything's filled. So now, next is the mounting configuration. This doesn't change the selection again. This only changes how it looks, how it's going to be mounted to make sure it fits correctly.
Gotcha.
So this is the application picture that the customer gave us. So again, this is assuming a lot of things for this example, but you can see it's in a vertical orientation. He may have something on this side that's blocking the gearbox from going over there, or it has another piece of equipment there, whatever the case. Assume there's no room around it and we have to fit this space. So for this example, we have all these different orientations. These are our shaft mounted BBB. So he said he wanted shaft mounted.
I was going to ask.
So we're going to stick to that, but what's the best way to mount it? Since he's got his motor on the top here, that tells me his electrical conduit is already up there. So he'll probably want to keep that as simple as possible. So with that, this Y2 would probably be the best orientation for this application.
With the motor going up.
Motor vertically mimics it as close as we can.
Gotcha.
In this case, it gets rid of the belt and the pulleys and things because it's direct mounted, but it's the best situation for his application.
Okay.
So we have the mounting configuration. Now we can finalize the selection. So using the catalog, we needed a 50-to-1, but the closest ratio that we do have in our catalog is 53-to-1. So that gets the ratio that we need. And then we go by the input power that we calculated, which is the 31.25. So we need one that's more than 31.25. So down here, the one right below this is 25. So that's not enough, but this one's 34.2. So that directs us to a 4D170 is our selection for this application.
No, that's a little bit more than they need though.
Correct. So that's more, it's even more service factor that they're getting. They're getting a freebie service factor based on the ratings of the box.
Okay.
So if we calculated this out, it comes out to a 1.4 service factor on the reducer. The application's only 1.25 required, but we're getting a 1.4 on the reducer alone with a 25 horsepower motor. So they're getting even more of a safety net with this size of a reducer.
Gotcha. Okay. Makes
So
sense.
then from the selection, you would go through and do your nomenclature. Now, nomenclature is different for everybody, but in most cases, there's our frame size right there that we selected. There's our mounting orientation, and there's our ratio.
Yeah. So every manufacturer has a different nomenclature set up.
Correct,
So you would
correct.
probably go to
The
the
ratio
catalog.
might be in a different spot or whatever
Gotcha.
the case may be.
Okay.
So just check whichever catalog you have
Yeah.
and we can make it match. But the selection process will be the same.
Gotcha. And typically that nomenclature is in the front of the catalog, right?
Yeah,
Okay.
we're using the beginning. They show all the mounting orientation, something like this.
Yep.
All the available ratios, things like that. So they tell you where to start and then you go through the process and finish it off.
Easy enough,
Yep.
I think.
Yeah, for now. They do get more complicated. I mean, there's some applications where variable speed, you have to compensate for the worst case, or if the loading changes every once in a while based on the day, you always want to plan for the worst case. So if one day out of the week, it works twice as hard, you want to be prepared for that. You don't
Gotcha.
want to deal with or you don't want to look at the rest of the time where it's barely running. You want to look at worst case because you don't want these things going down.
And I know we didn't incorporate any of the environmental features
Right.
into this selection, but assuming, we needed to account for those things, where would we find that information?
So again, in the catalog, the options packages, just an example for high temp or low temp. If it's really low temp, we may want to change the grease, and the rating may change with the grease. So that may change our selection if it's really cold.
Okay.
Same thing with the high side. If there's a D rate for using in a high temperature environment, it may change that service factor. So that gearbox was rated at 34. It may be only 32, 31 if you're doing high temperature, or if it's at a high altitude, there may be a D rate involved. So that's where you really need to know your environment as well, if that's the case. But in our case, it was normal sea level. It wasn't high temperature. It was high humidity, but that doesn't change the selection. That would change the breather. That would change the seals, things like that. So it wouldn't change the root of the selection would stay the same.
Gotcha. And I have to throw this in there too, but I mean, we did this kind of the old fashioned manual way, right? Where we gather the application details, we look through the catalog, but I mean, I know we have a configurator, but a lot of manufacturers have configurators as well. Can you do this same process in an online tool as well?
Absolutely. You need the same information.
Yep.
So you may have to do a little bit of math as far as RPM and any torque or speed that you may have to get to, but they usually have fields that you just fill in. I need this service factor, this type of reducer, and this mounting orientation, and it'll spit out that nomenclature for you. So yeah, there is always tools like that available, but it's always good to do it this way too.
Yeah.
Just so you understand the process,
Sure.
in case something gets missed.
But it seems to me though that the best way to get there to a proper selection that's going to last is to make sure we have all that application information captured up front, right? Because without that,
you could miss something. You're going to miss something in the application, and it could fail prematurely, and nobody wants that. No application likes when things go down. So.
And I'll ask another question. I mean, in that example, his motor was tripping out. I mean, does that mean that the selection that was initially put in there was bad, or does that mean maybe the factors have changed in that application over time and now it's different?
Yep. What we're seeing now is the applications are changing what they used them for 20 years ago.
Yep.
They're using them for twice that now, and they don't change anything else.
Yep.
Just see shipping anything, how long it takes. We're shipping more than we ever have. The gearboxes haven't changed, so we need to take that into account. So if you have a situation where it is tripping out, it may be good to look back history-wise. What changed? Something changed over time for it to allow that to start happening. Because at one time it was okay, but now it's not. So you really need to understand the full picture of the application, the history of it, as much as they're willing to share with you. A lot of times it's not available, so you do make a lot of assumptions or inferences, but you have to make sure you cover yourself and get all that information.
Gotcha.
And if you can't make the selection yourself, the person that's going to help you, whether our customer service or our technical support, they're going to need that information too. So get that information. That's the best place to start.
And the last thing before we move on to the next part of this session is, it's a little plug for you, but in that example, the motor's tripping out, right? So the motor's kind of acting as a fail safe.
Right.
In your world, condition monitoring, I mean, there's products that kind of help with that, right?
Oh yeah. Yeah, so our CycloSmart system would do that exact same thing way before it started tripping out.
Yep.
It would notice that the vibration level's going up, or the motor's starting to pull more amperage than it has. It gets that trend, that history information, as I mentioned before, that nobody else is looking at or nobody else is going to record. So you can prevent that type of failure before it happens. So condition monitoring is a big thing right now.
Yep. And
our system will definitely help us that type of scenario.
And all this is about asset optimization, total cost of ownership. And I think that if you haven't considered a condition monitoring system, or you're not using something that is helping you get in front of some of these issues, with your preventative maintenance, you ought to be looking at that, because that's really
we all know these things don't last forever. We would love them if they did 30, 40, 50 years, but in a lot of applications, they don't last that long. So getting ahead of that failure curve is what the condition monitoring systems do. Be able to get as much life as possible without having that downtime along the way.
Yeah, perfect.
What would be ideal.
Okay, so we are going to pause and see if there are any questions on the line. I'm going to go here to the chat and see if we've got any questions. Doesn't look like we have any questions that have been posted in the chat. So I will encourage you again to, if you have questions, to post them. We do have one. Are the ratings mechanical or thermal? That's a good question.
In the gearbox, in the catalog, excuse me, they are mechanical.
Yep.
So the example we showed was our BBB product here. Thermal with the cyclo advantages, we don't really mess with thermal too much until it gets into the really hot temperatures. Our mechanical rating is always the limiting factor.
Gotcha. Okay. Doesn't look like we have any additional questions. So we're going to go ahead and move on to the next session. Again, I would encourage you all to post any questions if you have them. We'll be glad to answer them. But now that we've made a selection, assuming the customers place their order and order the gearbox, right? The next thing they have to do is install it. But I'm sure you don't want to just go install in the gearbox without checking a few things first.
Let's make sure.
Yeah, just make sure.
Let's make sure it's what we ordered.
Yeah, that's right. Yeah. So talk to us about pre-startup inspection. And I think to do this, I'm going to switch places here.
So we have a few different examples here, but so say we went through that selection process. We needed a Y2 unit. So we ordered it. So now that it's ordered, we have it sitting here on our bench. We're ready to go through the process of installing it. But first, there's a whole bunch of things we want to check for. So first, let's make sure it's the unit we ordered. So here's our Y2. We'll go over here to the name tag and make sure it's the correct selection. It's the right frame size. It's the right ratio. In this case, we didn't order it with a motor. So our existing motor, make sure it's the right frame size at that motor adapter here. So our motor will bolt right to it. You're going to check all that. Make sure it's what you ordered. From there, you want to check the oil level or if it came with oil. So some reducers, depending on the company, they don't come with pre-filled. So if it's going to a low temperature application or they want to use special oil, they won't come filled. So you'll have to fill it up. You want to fill it up to the correct marks. These will be marked here, or some places there'll be a bullseye gauge somewhere along the middle. You want to make sure you fill it with not only the correct quantity of oil, but the correct type of oil. So we want to make sure. So like for a cyclo, for example, we mentioned the cyclo being different. The cyclo doesn't take every synthetic. It's only certain synthetics are compatible with the cyclo. So make sure it's on for us, it's on our approved lubrication list. If it's not on that list, avoid it because it may cause some premature failures. So make sure the correct oil is in there and the correct quantity of oil. Inside, attached to these, every unit when they ship is the accessory bag. So in there will be your breather. It'll be your coupling guards, any torque arm hardware. Make sure that's all in there. Make sure it's all correct for the install that you plan on doing, as well as make sure that the torque arm that you ordered is included as well. Or if you didn't order a torque arm, make sure the one you designed will mount up to the different mounting provisions on the gearbox and make sure it'll mount to your piece of equipment correctly. On the motor side, you want to make sure the coupling that came with the motor is correct for, or with the reducer is correct for your motor. Make sure it came with all the parts. So on this example here, we have a jaw coupling. We have 2 halves as well as the coupling spider inside it. So make sure it's the correct diameter for both the motor shaft and the reducer shaft. Things to check there. If that's all correct, you're good. And then lastly, you want to make sure the output shaft connection is correct. So both, it's what you ordered. So if it's a keyed hollow bore, it's the correct key, it's the correct diameter. Make sure everything is how you designed it, so it'll go onto your piece of equipment. In this case, these are our taper grip bushings. Make sure the bore of this is correct to what you ordered and what your piece of equipment has. Same thing here with our easy grip. This bore, these inserts are changeable. So you want to make sure this insert is correct for your shaft that it's going on. And then if all that's correct, you want to check the mounting platform that it's mounting on. So this is shaft mounted, so you want to make sure your torque arm pickup point is correct. You want to make sure it's welded properly, no chance of all that weight breaking the mount or anything like that. So you really want to take a look at that. And then if we slide over to here, this reducer is already mounted. So if we concentrate more on the mounting base here, make sure the mounting base is nice and level. A machined base is always preferred because that way we know the mounting pads are completely level to each other. If for whatever reason they're not level, you could always use a shim pack, something like this, to bring up one corner or one side to make sure it's nice and level. So level is best for torque transmission, but also for the lubrication as well. If it's level, the oil level will be accurate. It'll make sure all the components are getting lubricated correctly. And when you're mounting it like that, again, not only you're checking that it has oil in it, but the correct quantity. If it's at an angle, you may need a little bit more or a little bit less. So a lot of little things like that you want to check for when you're going to physically mount it on there. One last thing you want to check for, so if this has a chain and sprocket on it, you want to make sure you have the right chain, the right sprockets, the right ratio you need for your application. For the application we discussed before, it was a pulley. So make sure the pulley is the correct diameter for the ratio that we ordered. Because if it's not, your speeds are going to be off and you'll have to make some adjustments on the fly. So doing all this before you actually go to install it is a great way to make sure it's installed correctly and make sure the application does exactly what you want it to do. So once it's pre-checked, you're ready to install it. But I think we're saving that for next week, next time.
I think we have another session dedicated towards that. So I got a couple questions. I mean, we've got some guards and things here.
Mhm.
I assume we need to make sure we've got all of our correct safety equipment, guards, you know, anything else that's needed.
Right,
for
and not
safety,
just
right?
on the gearbox side. So these are
Yep.
the high-speed guards here. There'll always be a low-speed guard. Actually, if you spin that one around, you can
Yep.
see there's our low-speed guard there. Make sure those all guarded. Chain and sprocket, sometimes there'll be entire guard over that. You want to make sure you have that. That won't necessarily come from the gearbox manufacturer, but it could come from the equipment manufacturer to make sure it's on there, because this
Gotcha.
spinning around is definitely dangerous. You don't want necessarily anybody reaching in there when it's running. So safety is very important overall. So we want to make sure everything's there before you power it up and before you get this motor turning.
Yep. And then, you know, I know we're talking a lot about the products we've got here in front of us, which obviously are our products.
Right.
But for other manufacturers, I mean, a lot of the same stuff that you're talking about applies, whether it's bushings or keyed hollow bores or the other equipment that's shipped with it, right?
Right. So the industry standard, we follow industry standard in general as far as tolerances go and shaft fits and things like that. The only thing that's the 100% standard is keyed hollow bore. If you have a certain size shaft, the key that goes with it is exactly the same, no matter who you ordered it from. We try to do that to make it as easy as possible, and that's what the industry just does. But yeah, to your point, they have different style torque arms, so the torque arm pickups are different. You just want to make sure you designed on with CAD these days, it's a little bit easier to do that, to make sure you designed for the piece of equipment that you're getting to make it bolt in as easy as possible.
Yeah. So if you know, in that example we looked at, I'm sure it probably wasn't our unit, right? So
Originally,
we're replacing that unit. So if we weren't going with maybe a BBB and maybe we were trying to do something that was the like for like, right? There's some different factors that we would probably have to take into account when we're making that selection.
We would call that application either a retrofit
Okay.
or a full-blown replacement, which we've done before. We do
Gotcha.
that a lot. That takes a little bit more time because we would want drawings. We want to make sure it'll literally bolt into where that old one was.
Yeah.
But in some cases, it's not that easy or it's not required by the customer. So they just said, let's make a new design work and we'll retrofit it ourselves versus us making sure we bolt into their existing application.
Yeah.
So we can do either way. We have the capability to do that with CAD and different AutoCAD and Inventor and all that. It's definitely easier to do.
Also another good plug for the configurator, right? If you're doing that, some of those selections in the configurator, you can get some of those drawings.
Yeah, our configurator generates 3D models, 2D drawings, and all deliverable right to you at your computer. You don't have to wait for us to reply. Once you have that, you can take that into your model and mount it right on there. And you can see if there's any interference or see if there's going to be any issues before you even order the product.
Yeah.
So it's definitely a helpful tool.
Great. Well, I think, do you have anything else?
No, I think we covered everything. We're ready to install it next time.
Yeah. Okay. Well, we do have a couple questions in here. So one question is, could you give the formula to convert RPM in the last example? The 0.262.
So just give the formula. So it's the RPM, it's the feet per minute that they gave us divided by 0.262. You're gonna write, you can show.
Yeah, we're gonna write it down. We're gonna write it down. How about that?
So this is the RPM required based on given the feet per minute of the belt and the diameter of the pulley.
Okay.
So it's the feet per minute
Yep.
divided by 0.262 times the pulley diameter.
Times the pulley diameter. You sure about that?
Yes.
Okay.
I am sure about that.
Pulley diameter in inches. Right?
Inches, correct. Because that's, so the 0.262 is the conversion factor for inches to feet, and then taking pi into account to get revolutions.
Gotcha. And we talked about this in our last session about calculating feet per minute and the circumference of
Mhm.
circle and all of that. So if you didn't get an opportunity to watch that, we do have all of our videos on YouTube. So you can go back and watch that video and kind of get some of that foundation.
Yep. The more
and
specifics on there. Yeah.
That's right. That's right. We do have another question. A C-face motor can mount to the C-face adapter in any position?
Yes. So I'm assuming you're meaning any direction this way. Yes, the motor, a C-face motor will mount any way here. We can rotate it this way if that's what you mean. So if a conduit box is sitting here, you can rotate it every 90 degrees. The bolt pattern is symmetrical. It's a 4-bolt pattern. That's a NEMA standard. So if you're ordering a NEMA frame motor, this is a NEMA C-face. It'll mount up to that, and you can mount it any which way.
Gotcha.
Yep.
Okay. And then a couple more questions. What would be the best way to check rotation if there's a backstop?
Check it without the motor being powered.
Well, what if the motor's already connected?
So if it's already connected safely, obviously you don't make sure there's not power going to it. So if I'll use this reducer here for an example. With our safety guards, hopefully you can see that. With our safety guard removed here, you can go in here and you can turn the shaft. So if there was a backstop on this unit, it would only go in one direction. So if I go to turn it, this one goes both directions. If I go to turn it, it would hit that and stop. So that way you would know which direction you're going. So you mark it counterclockwise or clockwise, and then run your motor separately and see which way you're wired for. So you definitely want to do that beforehand, because if you go to turn it on and the motor spinning in the direction the backstop is acting,
Not a good
thing.
Not a good thing.
It'll break parts.
Yeah.
So definitely a good thing to check before you go to mount the motor and wire the motor.
Yeah,
for sure.
Good question though. Another question: should you also consider lagging into the pulley diameter in your formula?
Yeah, I would. In general, I would say yes. It's thin enough that it doesn't affect the calculation very much. But I would just do it as general practice, because it does change the overall diameter.
Okay, gotcha. Got another question. More questions this session I think we've ever had. So that's great. Can I change the mounting orientation of my gearbox after it has been ordered? That's a good question.
That is a good question. The answer is depending. Depending how you ordered it originally. So we showed Y2. So with a Y2 unit, if you can see here, there is some external plumbing. There is some minor seal differences on the input side. So if you were to want to mount this one vertically and you wanted to switch it to horizontally like this one is, we'd have to change a few things. We probably wouldn't recommend it in the field, but it's doable, but we'd have to send it back for that. So going from vertical to horizontal is the issue, whether it's motor down or up, switching that to horizontal. There's parts that change to keep the oil where it needs to be. And when you go to horizontal, you don't need as much oil. You don't need that level of protection of sealing.
Now,
So
what if it's not oil?
So if it's grease, you can mount it any which way. So the grease units do not have this external oil. They're completely greased. So those you can mount any direction. It doesn't have to be 90 degrees. It can be anywhere in between. Same thing with horizontal and oil. If you're going from Y1 or Y3 is what we call it. So horizontal this way versus horizontal this way, you can just flip that with no problem. You just change your breather location and your plug.
Gotcha.
So otherwise oil is going to come out of your breather. But grease is the universal one. You can put that any which way. Oil is the more critical one.
And for other manufacturers, again, I keep asking this question because, you know, I know there's some people on that may not use Sumitomo. We'd love for you to use Sumitomo, but you may not. So, you know, we want to be cognizant of that. You know, to make those changes, obviously consult with the manufacturer or their catalog to understand if you're going to do some mounting orientation changes. Yeah,
the key things there is just know where your fill and drain plugs are, where your breathers are, and your oil sight gauges are. Because if you do change, so this one was a grease unit. So normally there would be a sight glass right here. If you were to flip it and mount it a different way, the sight glass might not be visible. So you want to keep that in mind to make sure for long term, you can still see where the oil level is and do oil changes and things like that. But as long as you take all those 3 items into account, you can switch them with the correct direction.
Perfect. Okay. Let me look to see if we have any additional questions. Looks like we've answered most of them. I do not see any additional questions in the chat. So rather than keep you here waiting for any questions, we're going to go ahead and cut it. Anything else you'd like to add?
No, stay tuned for the next one.
Perfect. Well, look, we hope you enjoyed this session. And again, these are going to get progressively, I would say, more technical. And we're going to kind of go through that process. So today, obviously, we talked about gearbox selection, about pre-install inspection. So next session, we're going to go into detail around post-startup inspection. And I know there's quite a few things that we've got.
Yeah, what to check. So I mentioned chain and sprockets. So we'll make sure the chain and sprockets alignment, make sure that mount's okay, it's not moving around, all that. We'll get into a little bit more deeper information once it's installed and up and running.
Perfect. And again, taking you through this progression. So gearbox install, post-startup inspection. And then in August, we're going to talk a little bit about maintenance and just give you some general tips and best practices for maintenance. And then we're going to close out the summer with really just talking about obsolete gearbox replacement. We're going to get into some of the larger gearbox discussions, some of the higher dollar value gearboxes.
Ones that won't fit on this table.
Yeah, that's right. Ones where, you know, it really probably pays to understand what you're doing when you're either going to replace it or repair it. So we're gonna close the summer out to the end of August with that. Again, we're going to hang out for just a couple more minutes. If you've got any additional questions, we're just going to hang here for a few minutes, but we do appreciate your time. As always, thank you. Our videos are going to go out. So if you'd like to watch it again, we're going to send it out. As always, they're available on YouTube. If there's any other questions, please feel free to post them, and hope to see you in the next session. Thanks.
Thank you.